Welcome back. We are looking at Neco practical for mechanics aspect. Based on what they give to us, these are the masses that they ask us to supply for you in the examination. And based on these masses, I'll be working on these masses to formulate a table. And because I'm using the exact masses they ask us to provide for you in the examination hall, the table I'm providing is the likely table that you are going to see in your examination hall. So follow me through the video to see how I'll formulate table based on these masses they ask us to provide for you. And let's go to our experiment and use this setup to get our table out. Now we have come to the practical table now. What we want to do is that we want to do vertical oscillation of this my hanger that contain my masses. Now what we want to do is that we want to get the time taking for vertical oscillation of this my masses, and from our time we'll be able to get the rest of the value we need in the table. I mean, let's say our mass of 20 and take our time t1. So let's take our time 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 3.61. Let's take our t2, 3.72. Let's plot in another mass. This mass of 20 again, making it 40. Let's get our timing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 3.82. Let's get our T2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3.88. Let's go for 60. Another 20. To make it 60, let's get our timing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 4.03. Let's go for T2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 4.10. Let's go for the last one, which is another 22, which is our last mass that we are slotting for today. Let's get our T1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4.55 again. 4.55. So the next thing is to add our timing together and get our average. 3.61 plus 3.72 divided by 2. We have 3.66 is 3.67. 3.82 plus 3.88 divided by 2. We have 3.85. Then we have 4.03 plus 4.10 divided by 2. 4.065. Sorry, that is 4.00. We have this one, we also divide by 2, still give us 4.55. The next thing is that we so another value that I want to get now is period t, which is our time over number of oscillation. Our number of oscillation is what? Is 10. So we have 3.67 divided by 10. We have 0.367. Then here we have 3.85 divided by 10. We have 0.385. Here we have 0.470. We have 0.455. So the next thing here is that I want to square it. 0.367 square. We have 0.1346. 0.385 square. 0.1482. 0.407 square. 0.165
6. Then we have 0.455 square. We have 0.2070. So the next thing here.
So this is the table that we have gotten from our experiment, and we are plotting our t square on our vertical axis against m on our horizontal according to our question. So here you see that our t square here, we have another column for our t square here. The reason why we have this column is to be easy for us to plot our t square on our graph, because this is 0.1346. It will be difficult for you to locate this point on your graph. So we multiply this value by 100 to get this thing to get this value. But note that on this place you are going to say times 10 to the power minus 2, so that what you have here and this and here is what the same thing, because 13.46 times 10 to the power minus 2 is still the same thing as this one. So we just multiply this one by 1000 to get this value, but here it will be 10 to the power minus 2, so that it will be synonymous to this t square. So that's why we multiply this one, all this value by 100 to get this value to be able to get on our table. So here we have gotten our table that can help us to plot our graph. So the next thing is to plot your graph, which is t square on your vertical against m on your horizontal. So the next aspect here is the calculation aspect, where they ask us to calculate to get the value of our k here. But what to do here is, after you have gotten your slope, then you can calculate this aspect. So your slope here is your x, then this one you calculate k, and you calculate k here, and it will be your 4 pi square over x. Now the next aspect is they ask us to state two precautions and define this constant, Young modulus and first constant. I want to do that and drop it for me in the comment section. The next aspect is do the calculation aspect of this practical, and this practical is practical that's talking about Hooke's law. So I want you to follow me through my next video, because in my next video I'm going to treat this question and every calculation that has to do with Hooke's law. I'm going to treat it in my next video. So do not forget to like this video, share it with your friend, comment, and lastly subscribe.